Hi all, welcome back to Ashkemi once again. So today we'll have the part 13 of the question paper discussion that we were so far discussing. This video includes discussion regarding the topics aromaticity, SN1 and SN2 reaction, halogenation of olefin and crop reaction, a reaction exclusively for the synthesis of isokinalin. For those who have not gone through the previous video, I have created a playlist in the channel. So I'll be giving the link of the same in the iCard above. So those who are interested, you can just go through and watch the videos. And again, one important thing is I'm starting my online classes on May 2nd. So those who are interested, you can join. For that, you can just message to the number, WhatsApp number, which is given in the description box. So without wasting much time, we'll move on to the first question. The first question of the video is question number 46, which is a question from inorganic chemistry. So this is an odd one out. The rest of the questions are from organic chemistry. A complex has a composition corresponding to the formula COBr2Cl4NH3. What is the structural formula if conductance measurements show 2 ions per formula unit? Silver nitrate solution gives an immediate precipitate of AgCl but not AgBr. So you are provided with the condensed formula for a complex, which is a cobalt complex. The various ligands are bromine, Cl, that is bromine, chlorine, and ammonia. So the conductance measurement of this complex showed that it has got 2 ions. That is either positive or negative ion. It has got 2 ions, and moreover, an additional information is that when it reacts with the silver nitrate, it gives a precipitate of AgCl but not AgBr. So you have to find out the formula of the complex. So you are provided with 4 different options as well. So we'll work out that. So in the question, it is given that when the conductivity measurement was carried out, it gives 2 ions. So when you consider the different option, so first when you consider this option, this corresponds to a single ion which is having a plus 1 charge, and bromine is having a minus 1 charge. So this satisfies the first condition, that is it has got 2 ions per formula unit. But when it reacts with the silver nitrate, the product that we get is silver bromide, because only bromide ion is free. So these are the ion that is included inside the coordination sphere. So this cannot dissociate, but this is the one which is present outside the coordination sphere. So this can dissociate to form bromide ion. So it will react with silver nitrate to form silver bromide. But in the question, it is given that it gives silver chloride, not silver bromide. So option A is not the correct one. So this is the reaction that I was talking about. So this is the complex A. It ionizes in this particular form. That is, this will be a single positively charged ion, and this is bromide ion, and this react with silver nitrate to form AgBr, not AgCl. So this cannot be the option. So therefore, we can rule out the possibility for option A. Now coming to option B. Now coming to the second option, this is the complex that we are provided with, and this will be ionizing in this particular form. So it gives rise to 2 molecules of bromide ion and a positively charged complex ion. So when you count the total number of ion, it is 3. 2 plus 1, 3. So it doesn't satisfy this condition. And moreover, the reaction of the product with silver nitrate forms AgBr, not AgCl. So this does not satisfy both the condition. Therefore, we can also rule out the possibility for option B. Now coming to option C. Option C doesn't have any ions to ionize. It doesn't have any halogen outside the coordination sphere. So it consists of only a neutral complex or a neutral complex, and moreover it cannot give AgCl nor AgBr. Therefore, we can rule out the possibility of option C as well. Now coming to option D. The complex will be ionizing SCOBr to NH3 4 times plus and Cl minus. Okay. And therefore it satisfies the first condition that it has got 2 ion. 1 plus 1, 2. Now when it reacts with silver nitrate, it forms silver chloride. So it satisfies the second condition as well. Therefore, the correct option for this question is option D. The second question is from Aromaticity, which is an organic chemistry question, and you're asked to find out the compound that is not aromatic. Okay, so for answering this question, you need to have an idea regarding what are aromatic compounds. So how can a compound be classified as an aromatic compound? So a compound can be classified as an aromatic compound if it is cyclic and conjugated and also contain 4n plus 2 pi electron where n is equal to 0, 1, 2, 3, etc. You can also have another type of compound which is known as anti-aromatic, which satisfy the condition for aromaticity as cyclic and conjugated, but instead of 4n plus 2 pi electron, they will be having 4n pi electron. Therefore, the compound can be aromatic or anti-aromatic, but if it is not cyclic and conjugated, then the compound is classified as a non-aromatic one. Okay. So let's have the different options one by one. When you look at the first option, which is cyclopentadienyl anion, this is the structure of cyclopentadienyl anion. So this is a cyclic compound and it is conjugated because you are having alternate double and single bond, and this negative charge, that is also considered as a bond. Therefore, this is conjugated as well. When you consider the number of pi electron, it is 2 plus 2 plus 2, which is 6. So 6 satisfies the condition for 4n plus 2 where n equal to 0. I'm sorry, n is not equal to 0, n equal to 1. That is 4 into 1 plus 2. That makes a total of 6 pi electron. Now we'll have a look at the option B. So when you consider option B, this is the structure of cycloheptadienyl cation. So when you look at the structure, you can see that these two carbon atoms, they are sp3 hybridized. Whereas you consider all the carbon atoms in this compound, it is sp2 hybridized. But here both these carbon atoms are sp3 hybridized. So this compound is cyclic, but it is not conjugated. So you need not worry about the number of pi electrons. Since it doesn't satisfy the minimum condition for a compound to be aromatic, this can be considered as a compound which is not aromatic because it is neither anti-aromatic. For anti-aromatic, it would have satisfied the condition because it is having 4n pi electron. That is 2 plus 2, 4. 4n means 4 into 1, that is 4. But since these two carbon atoms are sp3 hybridized, that is not conjugated. Okay, so therefore the correct option for this question is actually option B. So this is the correct option. This is the structure of cyclopentadienyl cation. So this compound is cyclic, conjugated. Moreover, it has got 4n pi electron where n equal to 0. So this satisfies the condition for anti-aromatic compound. So this is an anti-aromatic compound, not an aromatic compound, but it is anti-aromatic. Okay. The last option is cyclopentadienyl ion. The compound that they have referred is actually ferrocene, which is a ion complex with the cyclopentadienyl anion, which is aromatic. Therefore, on the whole, ferrocene is aromatic. Therefore, we can rule out the possibility for option D as well. Therefore, the correct option for the compound which is not aromatic is the second one, which is cycloheptadienyl cation. Third question is about a question from substitution reactions in saturated system, that is SN1 and SN2 pathway. That is, which of the complex that is given in the different option will undergo reaction by both SN1 and SN2 pathway. So for that we have to have a small idea regarding the SN1 and SN2 pathway, about which we had a discussion, I think. So when you look at the nucleophilic substitution at saturated carbon, two mechanisms are actually possible, SN2 and SN1. S and N stands for substitution and nucleophilic. So in SN2 reaction, that is a single step reaction, or a concerted reaction which involves the formation of a transition state. Suppose you are having an alkyl halide and I have not specified the substituent. X is the living group that you have and Y minus is the nucleophile. Initially, Y minus will be attacking the carbon center from the opposite side, opposite to the side containing the living group to form a transition state in which the carbon atom is both half bonded to X as well as Y. Now, from the transition state, the living group will dissociate to form the final product. So, when you look at the stereochemistry of the starting product and starting material and the product, it was having the X on the right side, but now it is having the added nucleophile on the left side. So, most probably SN2 reaction lead to an inverted product because since a living group is there, Y cannot approach from the side containing the living group. Therefore, it will be approaching from the opposite side. That is why you are getting an inverted product. Now, this step, that is, it is a single step reaction and that happens to be the slow step. Therefore, the slow step involves both the alkyl halide and the nucleophile. Therefore, the rate depends upon the concentration of both. So, 1 plus 1, that is 2. So, this is a bimolecular reaction. That is why you are given a number 2 as the subscript. Sorry, superscript. Now coming to SN1 reaction, it is a two-step reaction in which initially in the first step the living group will dissociate to form a carbocation and you might be knowing that carbocation is having a planar structure. So this plane can be attacked. The nucleophile can attack this plane from either upside or the downside. So both are equally probable. Therefore, both the product will be formed. So the when you look at the stereochemistry of the final product, that will be a racemic mixture. So in case of SN2, it is an inverted product, and in the case of SN1, it is a racemic mixture. And moreover, the first step is the slow step, which involves only the alkyl halide. Therefore, the rate of the reaction depends upon the concentration of only the alkyl halide. That is why it is given a 1 subscript for unimolecular reaction. So now coming to the question, you are asked to find out the one which will which can undergo reaction through both the pathway. So when you look at the structural arrangement of the starting material, in the case of SN2 reaction, so we already had a discussion regarding SN1 and SN2 in one of our video. So in case of SN2, you can see that the nucleophile is approaching from the opposite side. Okay. Therefore, the substrate which is having a very small steric hindrance, that will be more favored. Therefore, when you look at different alkyl halide possible, that is primary, secondary and tertiary, the order of reactivity for SN2 reaction is as primary greater than secondary greater than tertiary, because primary is having the least steric effect, followed by secondary, followed by tertiary. Now, when you come to the case of SN1 reaction, that actually involves a formation of a carbocation, which is a reactive intermediate. And when you look at the stability of carbocation, it becomes more stable when there are electron donating group attached to the carbon center. Therefore, a tertiary carbocation will be more stable compared to secondary, compared to primary. Therefore, any reaction that lead to the formation of a stable carbocation, for example, tertiary carbocation, that will undergo SN2 reaction, sorry, SN1 reaction faster. So when you look at the order of reactivity of different alkyl halide towards SN1 pathway, the order follows like this. So the order for SN2 reaction is this one, and order for SN1 reaction is this one. So from these two combination, you can from these two cases, you can see that secondary carbocation is showing the same activity for both SN2 and SN1. If you consider primary, that opts for the SN2 pathway. And when you consider tertiary, that opts for SN1 pathway. For secondary, both the pathways are equally probable. Therefore, the alkyl halide which will react by both SN1 and SN2 pathway will be definitely a secondary alkyl halide. So from the option, you can see that this is the primary alkyl halide because there is only one carbon atom and the rest of the atoms are hydrogen. So this is not the answer. And coming to option B, that is also a primary carbocation because the leaving group is attached to the carbon atom, which is attached to a single carbon atom. Okay, so that is also primary. This is actually methyl and this is primary. Now coming to this one, here this is a secondary carbocation because the carbon atom attached to the leaving group is further attached to two different carbon atoms. So I'll give the structural formula for this one. This is the structure of this compound. Here you can see that the carbon atom is attached to two different carbon atoms. Therefore, this is a secondary alkyl halide. So most probably this will be the right answer. Now we'll just have a look at option D as well in order to conclude our answer for this question. So when you look at the structure of this one, this is a tertiary alkyl. The fourth option, this is a tertiary alkyl halide. I'll write down the structural formula for this one also. So here you can see that the carbon atom is attached to three different carbon atoms. So this mostly selects an SN1 pathway. So this is the right option. Now coming to the next question, which is about the reaction that cannot be employed for the preparation of alkyl halide. So you are provided with four different options and you have to find out the reaction which does not yield alkyl halide. So one option will not be resulting in the formation of an alkyl halide. Rest of them will be employed for the purpose. So let's have the discussion regarding different options. So what is Darson reaction? Darson reaction is actually a reaction for the synthesis of alpha beta epoxy ester by the reaction between carbonyl compound, which can be an aldehyde or a ketone, with alpha halo esters. Okay. So you are having a carbonyl compound that reacts with the alpha halo. This is an ester which is having a halogen in the alpha position. That reacts to form an epoxy ester, that is an epoxide containing ester as the side chain. So this is Darson reaction. So definitely that will be the correct option because it doesn't yield an alkyl halide. Therefore the correct option is actually Darson reaction, but we'll have a look at the other options as well. The second option is actually Mpv reduction. From the name suggests it is a kind of reduction, and Mpv stands for the scientists who have developed the first letter of their name, that is scientists who have developed this method, that is Mervyn, Pondorf and Worley reduction. So it is actually a reduction reaction of a carbonyl compound which can be an aldehyde or ketone to corresponding alcohol with the help of aluminium isopropoxide as the reagent. So this also seems to be the right option. So most probably this question will be cancelled because it has got two correct answers. Okay, so let's have a look at option C and D as well. Option C is Markovnikov's addition of HCl to an unsymmetrical alkene. So here you are having an unsymmetrical alkene which is 1-butene. So you are adding HCl. So according to Markovnikov's addition, the negative part of the added reagent, that is if you are using HCl, the negative part is Cl minus. That will go to the carbon atom with less number of hydrogen. That is when you consider the different carbon atom, this is the one which has got less number of hydrogen. So halogen will be added. So this is the Markovnikov's product. So this is actually an alkyl halide. Therefore, this is a method for synthesizing alkyl halide. So this is a right one. So you have to find out the reaction which is not employed for the purpose. So this is not the correct option. The last option is actually halogenation of alkene. So this can be considered as an example of halogenation of alkene where you have reacting alkene with the bromine molecule. So it forms a trans product. So depending upon the halogen that you are using, you can get product of different stereochemistry. Otherwise, it is a general term, that is halogenation of alkene. So either you can use this method or this can also be considered as a method for halogenation of alkene. So in all the cases, you'll be getting an alkyl halide. So these two are correct one. But these two options seem to be the one which does not lead to the formation of alkyl halide. So most probably this question will be cancelled because it has more than one right answer. So the last question for this video is question number 50, in which it is given that aniline reacts with glycerol in presence of sulfuric acid and nitrobenzene as an oxidizing agent. So what is the product that is formed during this reaction, or which of the statement is more correct regarding this reaction. Option A is Baeyer-Villiger oxidation and the product is quinolin. Option B is Rosenman reduction and the product is quinolin. Option C is Partner synthesis and the product is quinolin. Option D is Kropf's reaction and the product is quinolin. So to answer this question, we should have an idea regarding all these reactions. So let's discuss in a brief manner all these reactions. Baeyer-Villiger oxidation is actually an oxidation reaction where a ketone in presence of peracid. Peracid means it is having an extra oxygen atom. For example, metachloroperbenzoic acid, which is abbreviated as MCPBA, is a very good example for a peracid. So this react with a ketone. So that oxygen, one of the oxygen atom, extra oxygen atom in the peracid will be introduced into this ketone to form an ester. Therefore, Baeyer-Villiger oxidation is not the right answer because the product is an ester. Now coming to Rosenman reduction, it is from the name suggests it is a kind of reduction. It is a reduction of acid chloride to the corresponding aldehyde or a ketone. That is, the CO group will be the COCl group will be reduced to aldehyde in presence of palladium and barium sulfate. So the product will be a carbonyl compound. Therefore, that is not also Rosenman reduction is also not the right answer. Now coming to Partner synthesis, these two reactions, that is Partner and Kropf reaction, they are actually reactions of synthesizing heterocyclic compound. In Partner, it is a multifaceted reaction, that is using a single static material, that is 1,4-diketone. You can synthesize oxygen, nitrogen and sulfur based heterocyclic compound. That is for synthesizing furan, you have to carry out the reaction in presence of an acid. When it is carried out in presence of a base like an amine, it forms pyrrole, and in presence of P4S10, it forms thiophenol. Okay, so this is also not the right answer. Now coming to the last option, which is Kropf reaction. It is actually a reaction between aniline, that is aniline NH2, C6H5NH2 with the glycerol. This is the structure of glycerol, which is a trihydroxy acid, trihydroxy compound. It leads to the formation of isokinalin. The structure of isokinalin is two benzene rings fused with each other with one of the ring atom happens to be nitrogen. So for the right option for this question is actually option D, which is Kropf reaction. So that's all for this video. So thank you for watching. So if you find it useful, please do like, subscribe and share. And today I'll be uploading another video regarding the details of online coaching for those who are still hesitate to ask the details, and it will be a very useful course for you, and I'll be coming soon with the next part of this video, and till then, stay tuned.